Then from here, we have 2ab. Let us factor 2a outside. When we have 2a, from here, then a divided by 2a, we have here to be 1 divided by 2 plus 2ab divided by 2a. From here, we are going to have only b, then plus b equals 8. Then from here, let's add, we want to make sure that what we have here equivalent to what we have here, so we can factor them out. Let's add 1 divided by 2 to both sides. So we have 2a into 1 divided by 2 plus b plus this b plus 1 divided by 2 equals 8 plus 1 divided by 2. Then from here, we see we have 2a. Let's arrange b plus 1 divided by 2 plus, then plus this as b plus 1 divided by 2 as this equals, this one we find the LCM to be 2. We have this one to be divided by 1. 2 times this, we have it to be 16 plus 1. b plus 1 divided by 2, b plus 1 divided by 2 is common. So we can have them as b plus 1 divided by 2. The whole of this thing here divided by this, we have only 2a plus the whole of this here divided by this, we have only 1, will be equals 16 plus 1 will be 17 divided by 2. So we have this as this. Let us multiply through by 2. When you multiply this by 2 here, 2 times b, we have it to be 2b plus these 2, we cancel this one, we have only 1 plus here will also be 2a plus 1 will be equals this and this we also cancel. We have here to be only 17. Then we can express this 17 as, so we have this as 1 multiplied by 17. We can also have this as 17 multiplied by 1. So we have this as product of two numbers. So this implies that it's either we have 2b plus 1 to be equals 1, and let's name this as equals to 1, and we have 2a plus 1 to be equals 17. We have this one to be 2. Likewise, we can express them in terms of negative as minus 1 multiplied by minus 17. And again, we can also have it as minus 17 multiplied by minus 1. Then, from here, it implies that when we go along with this, 2b plus 1 will be equals minus 1. We have this as equation 4. And again, when we go along with this, we have 2a plus 1 to be equals minus 17. We have this as equation 5. When we go along with this one, we also have 2b plus 1 to be equals, for this one will be minus 17. We have equation 6. When we also go along, we have 2a plus 1. We also have it to be minus 1. We have this one to be equation 7. Then let's start from equation 1 and 2 that goes along with this. Then we have 2b plus 1 to be equals 1 from case 1. So we have 2b to be equals 1 plus 1 minus 1. When this one go here, then we have 2b to be equals 0. Therefore, our b will be equals 0 for this. Likewise, we also have 2a plus 1 to be equals 17. So we have this as 2a plus 1 to be equals 17. Then 2a will be equals 17 minus 1. And we have our 2a to be equals 16. From here, when divided by 2, we have our a to be equals 8. So for the first one, we have a comma b to be equals 0. So we have to be 8 comma 0. Then likewise, when we go along with this, where we are going to have 2b plus 1 to be equals 17, and from here we have 2b to be equals, when this one go here, we have it to be 16. Dividing 2 by 2, we have b to be equals 8. Then we are going to have 2a plus 1 to be equals 1. taking this one to this side, we have 2a to be equals 0. Will be 1 minus 1. Then we have a to be equals 0. Likewise, we also have another one from here. Or you have it to be 0, 8. The reciprocal of it. That's the first one when we go along with positive integers. Then let us go along with negative integers and see what will happen. So when we go along with this one, 2b plus 1 will be equals minus 1. And this implies that we are going to have 2b to be equals minus 1. Here will be minus 1. Then we have our 2b to be equals minus 2. This implies that our b will be equals minus 1. Likewise, when we also have 2a plus 1 to be equals minus 17, here will be 2a to be equals minus 17 minus 1. 2a will be equals minus 18. Dividing through by 2, we have our a to be equals minus 9. So, for the negative cases, we have a, b to be equals minus 9, minus 1. So, when you also solve for the second one where we have our 2b plus 1 to be equals minus 17, and we have here to be 2b will be equals minus 17 minus 1. It will be the reciprocal. 2b will be equals minus 18. Dividing through by 2, we are going to have our b to be equals minus 9. And when we also have 2a plus 1 to be equals minus 1, this implies that we have 2a to be equals minus 1 minus 1. Taking this one to the other side to change to negative, then we have 2a to be equals minus 2. Then from here, we are going to have our a to be equals, dividing through by 2, we have here to be minus 1. The second case will be a, b will be equals minus 1, then minus 9. The reciprocal of the other one. We have the second one as this, minus 9, minus 1. So now, recall that these are for the positive cases. When we have minus 17 multiplied by minus 1, and again, this one is for when you have minus 1 multiplied by minus 17, and everything will give us 17. This is for the negative. Then for the positive, we have a, b to be equals, the first one is 8, 0. Then you also have another one, a, b. The second one is 0, 8. These are for when you have 17 times 1 and 1 times 17, which will definitely give us 17 as well. Now we are looking for a plus b. From here, I think we can take it off the 1. Then it will be 8 plus 0 will be 8. That's the first one. The second one will be a plus b. From here, when we take it out of the 1, it will still be the same thing as minus 1 minus 9, and this will give us minus 10. So in general, we can have our a plus b to be equals 8, minus 10. If you are new here and you find this video interesting, don't forget to share, like, comments, and subscribe to our YouTube channel for more math tutorial videos. Bye-bye. Then recall, let's have it to the solution. That when you have a to the power of m plus n equals as a to the power of m dot a to the power of n. So by applying this theorem here, we are going to have here to be 5 to the power of a dot 5 to the power of 1 equals 50. Then let's divide 2 by 5. So this and this will cancel. We are going to left with 5 to the power of a equals 50 divided by 5. We have it to be 10. Then we have here to be 5 to the power of a equals, we can have 10 as 5 times 2. To get the value of a, let's introduce log. So this implies we have log 5 to the power of a to be equals log 5 times 2. So from here, this particular power will come down to the base here as a log 5 equals this one, we change to addition as log 5 plus log 2. So what we need to do here is to divide through by log 5 to get a. So this and this will cancel. Then we have our a to be equals log 5. Let's distribute this particular log 5 for this and this. So everything here will be divided by log 5 plus log 2, this divided by this log 5. So log 5 divided by log 5 will be 1 plus. Now recall, when you have log a divided by log b, this equals as when you have log of a in base of b. So let us apply this ideology that is equivalent to this here. So we are going to have this to be log 2 in base 5. So finally we have our a to be equals 1 plus log of 2 in base of 5. Now to check, we have 5 to the power of a plus 1 that equals 50. Then when a equals this, let's see what will happen. We are going to have it to be 5 to the power of 1 plus log 2 in base 5, then plus 1, then is it going to give us 50? Mind you, we have 1 plus 1 will be 2. We have 5 to the power of 2 plus log 2 in base 5 is going to give us 50. Then we have this as 5 to the power of 2 dot 5 to the power of log 2 in base 5 is going to give us 50. 5 to the power of 2 will be 25. Then multiply by 5 to the power of log of 2 in base of 5, then it's going to give us 50. Mind you that when you have a to the power of log of b to the base of a, the output of this will be b. So far the base are the same here, the output will be b. Here also the base are the same, the output will be 2. So this implies you have 25 multiplied by 2, then it's going to give us 50. So 25 times 2 will give us 50, which equivalent to 50. Bye-bye.